So, calculus exam questions. Ed McEntee wanted these. He's given out that there was none done. So here they are. Differentiate a third x squared minus x plus 3 from first principles. So f of x is equal to a third x squared minus x plus 3. So this, you've learned this off. You're following the same procedure each time. F of x plus h is a third times x plus h to be squared minus x plus h plus 3, which is equal to a third times x squared plus 2xh plus h squared minus x minus h plus 3, which is equal to a third x squared plus 2 thirds xh plus a third h squared minus x minus h plus 3. So this is my f of x plus h. Now we need to take away f of x. So minus f of x is going to be minus a third x squared plus x, line them up, and minus 3, which is going to give me 2 thirds xh plus a third h squared minus h. Now what is the answer to this when it's differentiated? We're going to get 2 thirds x minus 1. So you should see where this is coming from. Now at this point you can see your 2 thirds x in here, and how do I get a minus 1? I divide by h. So you've learned this off, so you should be brilliant at these now. So I'm going to have to divide f of x plus h minus f of x by h. So f of x plus h minus f of x divided by h is equal to 2 thirds x plus a third h minus 1. So how do we get rid of the h? Well, we say the limit as h tends to 0 of f of x plus h minus f of x divided by h is equal to 2 thirds x minus 1. And that's different, 2 thirds x minus 1. That's your differentiation from first principles. Okay, next question. F of x is equal to the natural log of 3x squared plus 2. G of x is equal to x plus 5. Find the derivative of f of g of x, this composite function here, function inside a function, at x is equal to a quarter. Okay, so we need to put g of x inside f. So this x plus 5 goes into this x here. So f of g of x is equal to the natural log of 3 times x plus 5 to be squared plus 2, which is the natural log of 3 times x squared plus x by 5 twice, which is 10x plus 25 plus 2, which is the natural log of 3x squared plus 30x plus 75, and I'm going to have to add that 2, so plus 77. So the derivative of this f prime g of x, if we differentiate the natural log of x, it becomes 1 over the function multiplied by the function differentiated. So 1 over 3x squared plus 30x plus 77. And differentiating 3x squared, I'm going to get 6x, and differentiating 30x, I just get 30. So we end up with 6x plus 30 over, and I'll just extend the line here, 6x plus 30 over 3x squared plus 30x plus 77. So we want f of g of a quarter, this quarter here, f prime g, when x is a quarter, is going to give me 6 by a quarter. And this decimal places, we're looking for 3dp. I should have written that down, 3dp. So this is calculator use. Don't try and simplify it. 6 by a quarter plus 30 over 3 by a quarter squared plus 30 by a quarter plus 77. Type this into your calculator. Clear your calculator, type it in again. Make sure you get the same answer twice. If you don't, you're going to need to do it a third time. Mine is giving me 0.372, and yours should give the same if your calculator is working, or if the person inputting the data is working correctly. On to the next question, with the washing machine really annoying me in the background, so if you can hear it, I apologize. Right, the function f is such that f of x is equal to this cubic function. Show x equals minus 3 is a root. Don't confuse with a factor. Find the other two roots. Okay, I think the best way to do this, if we're going to find the other two roots, we need to find the quadratic that when we divide this factor in, we will get. So if it's a root and we divide it in, we're going to have no remainder. So we could also just sub in x equal to minus 3 here, and it will be equal to 0. That's another way to show it's a root. But in this case, we're just going to divide it in. Divide my x equals minus 3 is my root. So x plus 3 equals 0 is my factor. So just be careful not to divide x minus 3 in. X plus 3. Just change the pen color. So x into 2x cubed, 2x squared. 2x squared by plus 3 is plus 6x squared. These two boxes are my x squared. I want 5 of them, so I need to take away 1. X into x squared is minus x. Minus x by plus 3 is plus 3x. These are my x boxes. I want minus 4, so I need to not make any mistakes here. That's a minus 3x. So we need minus 4, so minus x up here, and x into minus x is minus 1. So my quadratic to solve is 2x squared minus x minus 1. This will give me the other two roots. Has to be 2x times x. Has to be 1 times 1. And we want minus x, so it has to be minus 2x plus 1x. So my other two roots are x is equal to minus a half and plus 1. So next part of this question, we're asked, I've drawn them all together up here. We're asked the coordinates of the local max and local min. So we know, I'm going to sketch this cubic first. So my roots are at minus 3, minus a half, and 1. So minus 3, minus a half, and 1. And it's just a sketch here to try and show us something. So there's two roots on the left hand side of the axis. And let's say that root there is 1. So if I draw my y-axis just approximately here. So I've got my 1, my minus a half, and my minus 3. So I need these turning points. We're looking for the local max and local min. So here's my local max, and say here's my local min. So the slopes of these are equal to 0. And we're going to use this information now in a minute in the next part as well. So let's see what these local max and local min points are. So we say dy dx is my slope. So just let's get dy dx here. So differentiating this guy, we're going to get 6x squared plus 10x minus 4. If I factorize that one, I'll try 3x by x. Actually, I can divide it by 2. I'm going to get 3x squared plus 5x minus 2. Now we get the same answer. It doesn't matter which way you factorize it, but this is easier now because there are two primes again. We had a prime, a 1. We have a prime and a prime. Makes it easy to factorize, and this does happen a lot. 2 by 1. So the 6x, 1x, we want plus 5 plus 2. So what are my solutions to this? My x values are 1 over 3 and minus 2. Now the x 1 over 3 has to be my min in here. That's my min and my max, but we're asked to find the points. So I've got to sub these back into the original equation. So let me do that. 2x cubed, 2x cubed plus 5x squared minus 4x minus 3, and that's going to give me, if I put a third in, this gives minus 100 over 27 on a calculator. We could write that as a decimal, but let's leave it as a fraction. It works out nicely. And if we put minus 2 in, 2 by minus 2 cubed plus 5 by minus 2 squared minus 4 by minus 2 minus 3, it has to give me a positive number up here, and it does. It gives me 9. So my minimum point is a third minus 100 over 27, and my max is minus 2, 9. Now the sketch will help me with the third part of this question. F of x plus a, where a is a constant, has only one real root. So this is my complex root. So this cubic can only cross over the x-axis at one point. Find the range of possible values for a. Well, these values are going to help us here. So if I just sketch it again and go like this. So for it to have only one real root, this graph, if I sketch another color, would have to be coming up like this, down like this, and up like this. So this point here would have to shift down. And similarly, we change my color again. If we move it up, if this point has to shift up, where does it have to get to? Crosses the x-axis there, one point. Down here, can't touch it, so that's not touching. You can see a tiny gap. So this has to shift up this much. So a would have to be, at this point, we have minus 2, 9. So a would have to go down 9. A would have to be greater than 9 at this point. Well, no, it's going down, so it has to be taken away 9. A would have to be less than 9 at that point. And we're going up here, so it would have to be greater than, and what was this point, 100 over 27? So a would have to be greater than 100 over 27 to shift that graph up more than 100 over 27 to get above the x-axis. So these are my two answers for the last part of this question. The next question is about the height of water in a port measured over a period of time. The average height was found to be 1.6 meters, and the height measured in meters, h of t, this function is 1.6 plus 1.5 cos pi over t times 6, or pi over 6 times t. T is the number of hours since the last recorded high tide, and obviously pi over 6 times t is expressed in radians. So the period and range. Well, the period is always given to me by 2 pi divided by the coefficient of time, which these functions normally always are. So the coefficient here is pi over 6. So 2 pi divided by pi over 6 is equal to 2 pi times 6 over pi. My pi's cancel, and I'm left with 12, and time is hours. So my period is 12 hours. My range, well, the range of values that this could be is my max and min values of cos, which you've seen loads of times at this point. So max cos equals 1. My minimum cos is equal to minus 1. So I'm going to have 1.6 plus 1.5 and 1.6 minus 1.5. So the max is 3.1 and the min is 0.1. So that's my range. So range is written in square brackets. It goes from 0.1 to 3.1. And actually we found the max height here, part B. Strange question, seeing as we've already kind of gotten that information. The max height is 3.1 meters. So a couple of easy questions to start this leading cert higher level question. Find the rate. Once we see rate, we're thinking dy dx, or in this case we're dealing with dh dt. So h and t, or h prime t, we probably just use h prime t. So we need to differentiate this function. So let me write the function out again. H of t is equal to 1.6 plus 1.5 cos pi over 6 times t. So cos goes to, you're all telling me minus sign. 1.6 goes to 0. So h prime t is equal to minus 1.5 by the sine of pi over 6 times t. And then we have to differentiate this pi over 6 times t. Well, 5t will go to 5. So pi over 6 times t goes to the coefficient of t, which is just pi over 6. So once we get this pi outside of the angle, it reverts to being 3.14. So we're asked for h prime 2 when t is 2. H prime 2 minus 1.5. Is it decimal places? It's 2 decimal places. So it's calculator use here. You can use radians on your calculator, or if the angle works out to be fairly straightforward, what are we going to get? We're going to get 2 pi over 6, which is pi over 3. So we're going to get 60 degrees. The sine of 60 is root 3 over 2. So just use radians on your calculator, or type into your calculator minus 1.5 by the sine of, we said pi over 6 30 by 260 multiplied by 3.142 or 3.14 over 6. And that comes out to be minus 0.68. And you're asked to explain your answer. These real project maths questions, well, explain your answer in the context of the question. So this means the water is going down. So what is it going down by? 0.68 meters per hour. We're dealing in hours here. So the water is going down. You could write that. The water is going down at 0.68 meters. And that's when t is equal to 2. Or 2 hours after. Well, it doesn't say after the last high tide, but in the next part it will kind of give us information that we could say that t could be maybe 2 a.m. On a particular day, high tide occurred at midnight. T is equal to 0, so that's where 2 is, where I got the 2 a.m. from. So we were just given this table here. We were given that midnight was 0 hours, and we just have to fill the information in. So at midnight, high tide occurred. So that's my 3.1. Now, can we do this without a calculator? At 3 a.m., t is equal to 3. So the cos of 3 pi over 6 is the cos of 90. That actually is 0. Cos of 90. So we're just going to have 1.6. So after 3 hours, we have 1.6. And we should see a pattern here with these graphs because it's up and down. 6 a.m. is going to be the cos of 6t over 6, the cos of 180. And the cos of 180 is minus 1 based on our unit circle. Do we need to do a little unit circle? 180 over here. Well, that's a bit of a wonky unit circle. So we have our cos being 1. So that's the point 1 0. So cos is 1 at 0. 0 1. Cos is 0 at 90. Minus 1 0. Cos is minus 1. And 0 minus 1. So cos is going to be 0 at 270 again. So we're saying here that that's 0, so we're just going to get 1.6. Sorry, here we're going to get 1.6. Now we're at 180, so minus 1.5. After 6 hours, we're going to get 1.6 minus 1.5, 0.1. At 9 hours, just do some rough work up here. The cos of 9t over 6 is... Sorry, 9 pi over 6. 9 pi over 6 is 30 by 6. 30 by 9, 270, which is that point 0 minus 1. So again, we're going to get a 0, so it's going to go up to 1.6 after 9 hours. Is this my pattern now? Will 12 get me back up to 3.1? Let's have a look. The cos of 12 pi over 6 is going to be the cos of 2 pi, which is 360. So that's going to give me a value of 1. The cos of 360 is equal to 1. So I'm going to get back up to 3.1. 1.6 plus 1.5 here. That's after 12 hours. And we should see the pattern here. You can double check these, but it will revert back to going back down to 1.6 after 15 hours. Down to 0.1 after 18 hours. After 21 hours, it has to come back up to 1.6 before finally getting back up to 3.1 after 24 hours. Now you're asked to sketch this graph. So let's have a go at sketching that. At midnight it's 3.1. Now, in the exam you were given square diagram and all these values on. You didn't have to draw the graph yourself. Now if I just put in some of the values, when are my lows and highs? My low is 6 a.m. 0.1. 6 a.m. here, about 0.1. I can put in all the values. Let's put in 3 a.m. as well. 1.6 at 3 a.m. It's easier to sketch them without all the points because you're going to miss the points as you go down. So let's just put the lows and highs. So it's 12 noon, we're back up. 12 noon, back up to 3.1. 12 noon, approximately here. Now, you guys will have squared paper for this, so it should be perfect. And then 6 p.m. is my next low tide. Just double check. 6 p.m. 0.1. Then we are back up to high tide at this 12 p.m. So approximately here. So I'm going down. It's going down. Up. Down. Up. So not a bad effort at a sketch. They're slightly off, but not too bad. So let's have a look. There's a following question, something from the graph. Find the difference in water height between low tide and high tide from the graph. Now this was already asked. Something similar in part A. So what's low tide? We know it's 0.1. High tide, 3.1. So the difference between low and high is 3.1 minus 0.1, which is 3 meters. The difference between low and high. And the last part, I think, is this the last part? Yeah. A fully loaded barge enters the port, unloads its cargo, and departs sometime later. The fully loaded barge requires a minimum water level to enter of 2 meters. Okay, let me put that on straight away. 2 meters is here. So it can enter here, 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 or here. And then when the barge is unloaded, it only requires 1.5. Okay, well, let's put that on first. 1.5. 1.5 is somewhere along here. So just put my points on. Let's see what they're asking us here. I think it's the maximum amount of time spent. So the maximum amount of time the barge can spend in the port without resting on the seabed. Okay, so when can he enter? What does he need? He needs nothing else given to us. The max amount of time he can spend. Okay, let's have a look at this. So if he enters here, he would have to leave by here. So that's quite a short period of time. We're looking for the max here. When else can he enter? He can enter here, and until he can stay at all of this time until it gets back down to 1.5. And similarly, he could enter at this point, but that's taking us off the graph. So it must be this one here. He can enter at, what time is this? He can enter at, looks like it's about 10. And he'd have to leave before this point here, which looks about 4. So it looks to me about 10 AM to 4 PM is that band there. So it looks like he can spend about 6 hours in the port, 10 to 4. Max amount of time, I'm going to say 6 hours from my graph, which is the answer to this question. Next question, if y is equal to x times the sine of 1 over x, find dy dx. Okay, so this is a product rule. We could write it as x sine x to the minus 1. That might be easier than using the sine of x over a. I think we'll use that one. So the first, I'll write it down here. Y is equal to x sine 1 over x. Y is equal to x by the sine of x to the minus 1. So differentiate both. I'm going to get 1. Sine goes to cos. So cos x to the minus 1 times 1, if you wanted to put that in. And it's not times, we got to differentiate x to the power minus 1, which is going to be minus x to the minus 2, which is minus 1 over x squared. So there is a product within this product rule. So that's times minus 1 over x squared. That's what that differentiates to. So I have my two parts. So now let's do dy dx. The first, x by the second differentiated, which is cos x to the minus 1. Times minus 1 over x squared. That's the first by the second, plus the second, sine x to the minus 1. By the first differentiator, which is just 1. Okay, let's tidy this up. This is x by the cos of 1 over x. I have a minus, and there's an x squared on the bottom, so that's going to give me minus 1 over x by the cos of 1 over x. That's the first one tidied up, and then I'm going to have, well, just the sine of 1 over x. Don't think this can be tidied up anymore. What else are we asking this question? The slope of the tangent. Okay, we have dy dx. And we're asked to find the derivative, or the slope of the tangent of the curve when x is equal to 4 over pi. Okay, if x is equal to 4 over pi, well, let's just do this quickly. 1 over 4 over pi is equal to 1 times pi over 4. So that's where the angle will come from here, pi over 4. So we're going to have minus pi over 4 by the cos of pi over 4, which is 45, plus the sine of pi over 4. So tidying this up into a calculator, 2dp gives me 0.15. On to the next question. Air is pumped into a spherical, write down sphere, 4/3 pi r cubed is the volume of a sphere, at a rate, so we're looking at calculus again, at 250 meters cubed per second. Okay, what's going on here? So let's write down our information here. We have V of a sphere is 4/3 pi r cubed. So what can we do with this? We can get dV dr, which will help us in this question identify what we need to do, which is 3 by 4/3 pi r squared. Air is pumped in and it's going in, so the volume is increasing. So if the volume is increasing, that's dV, volume over time. The volume is increasing over time at a rate of 250 centimeters cubed per second. So dV dt is 250. Find the rate at which the radius is increasing. Okay, well the radius has to increase over time too, so we're looking for dr dt. So we write out our chain rule. Dr dt, based on the information that we have, is dr dv times, we need that dt on the bottom, so we'd have to have dv dt on top, and you can see here the dv's cancel, just leaving us with dr dt. So what do we have? We're looking for dr dt. Dr dv, well, dv dr is 4 pi r squared over 1, so that's going to be 1 over 4 pi r squared. And dv dt is this 250. And we're told that the radius is 20, so dr dt, when r is equal to 20, is 1 by 4 by 20 squared by pi, and there's a 250 on top here. So what have we got? 400, 1000 on the bottom, no, 20 squared, 400 by 4, 1600. So we have 250 over 1600 pi. That simplifies down. 25 doesn't go into 160, but 5 does. So 5 into 25, 5, and 5 into 160, 32. So 5 over 32 pi, and that'd be centimeters per second. In part B, we're asked to find the rate at which the surface area, so that's area. Now area is volume differentiated, 4 pi r squared. That's the area of a sphere. When the radius is 20 as well. Okay, so we're looking for the rate at which the surface area is increasing. So area over time. And we can get the ADR here. That'll help us figure out what the third element of this chain rule is. The ADR is 8 pi r. The ADT, find a rate at which, that's what we're looking for, the ADT, so that's equal to dA, dr. We got to have the t on the bottom, dt, so that's going to be dr dt. Now, was dr dt what we had here? Dr dt was the previous question. So, the ADT is equal to that 5 over 32 pi, and the ADR is 8 pi by 20. Okay, does this simplify down? The ADT is 8 goes into 32 4 times, and 4 goes into 25 times. That's going to leave, and the pi's cancel. So that's just going to leave 25. And that is also in centimeters squared per second. So that's the area increasing when the radius is 20. Next part. The inflated ball is kicked in the air from a point O on the ground. O is the origin. Okay, let's do a little sketch here. Here's my O. And we're told that this function is minus x squared plus 10x. Well, we know that's going to be an inverted U. I don't think we're asked for max height here now. Average height is the next one, so that's integration. So the 2 times when it's on the ground, we can say that the height is 0. So find when that's the values when the ball is on the ground. So we'll say minus x squared plus 10x is equal to 0. X squared minus 10x equals 0. X by x minus 10. So this is my initial here. x is equal to 0, and x is equal to 10 at this point. X is equal to 10, so that's 10 seconds to the time when the ball is kicked when it hits the ground. Quite a long time. The average height of the ball, well, the average height is integration. So the integral of minus x squared plus 10x between my values of 10 and 0, and the average is 1 over b minus a, or 1 over 10 to get the average, so we're getting a tenth of each interval. So we're going to get minus x cubed increased to power minus x cubed divided by 3 plus 10x squared divided by 2, which is 5x squared, 10x squared over 2, and that's going to be between 10 and 0, and we're going to get a tenth of it. So the 0 is going to give me a 0 value, so it's just a tenth of minus 1000, 10 cubed over 3, plus 5 by 100, 500. So that's going to give me, well, I'll separate them both, 10 into 1000, that's a minus 100 over 3, so minus 33 and a third, plus 50, and that's going to give me 16 and a third meter. That's the average height of this ball. Okay, let's look at the next question. Is there one? No, last question in this video. So it's half an hour long. It's a good bit of exam question practice, so I'll leave it here.